Welcome to Vision Plus and welcome back to S.4 Mathematics. We are looking at finding the gradient of a curve at a given point. Example 2 part A says, find the gradient of a curve y equals to x into 2 minus x at the point x equals to 2. So for us to find the gradient of the curve at a given point, we need to first get the gradient function of that curve. And for us to get the gradient function, we simply need to differentiate the given function of the curve. So if we look here, we have two terms in a bracket and then we have one term outside. So we need to expand this so that we have y equals to x times 2, it is 2x minus x times x, it is x squared. So this is the curve. Now let us get the gradient function. That means dy dx equals to, we differentiate this function. Remember, if you are differentiating the curve, the choice is yours. One, you can use the method of powers and coefficients, which is quicker and it takes you 2 or 3 steps, or you can use differentiation from first principles, which will take you almost a full page. So what do? I recommend that if the question has not told you to use first principles, do not use it because it is lengthy and the chances of making errors are very high. So let us use here the method of powers and coefficients, which I'm going to always be using unless the question has stated clearly. So if I differentiate 2x, I get 2. If I differentiate 2x, I get 2 minus, if I differentiate x squared, I get 2x. So this is the gradient function of the curve. The purpose of the gradient function is that it tells us what the gradient of the curve would be at any point on the curve. But now they're saying at the point where x is 2. Remember, when x is 2, that means this is on the x-intercept. That simply means that y is 0. But remember, the value of y or the coordinate y is not important for us in the gradient function. Why? Because the gradient function is only defined in terms of x. So it doesn't matter what the value or the coordinate of y is at any point. So using that point, which are now said therefore dy dx at the point where x equals to 2. This one now is going to give us the gradient of the curve at the point when x is 2. And we know when x is 2, it means y is 0 from our coordinate geometry. Equals to, let me substitute. So we shall have here 2 minus 2 times x. What is x? X is 2. Then we press the calculator. We find that we are getting negative 2. Therefore, the gradient of the curve at the point x equals to 2 is negative 2. We have a negative gradient. That is the solution to part A. And now going to part B. Part B says, find the gradient of the curve. Part B, and the curve is y equals to open bracket 4x minus 5 squared at the point half and 9. This is the point half and 9. So we need to find the gradient of that curve at that given point. What do? Always we start by getting the gradient function of the curve. That means we need to differentiate this curve. And for us to differentiate this curve from the methods that we have learned, we need to expand the bracket because it is square. That means we shall have y equals to 4x minus 5 times x minus 5. Then we expand. 4x times 4x, it gives us 16x squared. 4x times negative 5 is negative 20x. Negative 5 times 4x, it is negative 20x. Negative 5x times negative 5 times negative 5, it gives us positive 25. So let us further simplify. This gives us here 16x squared. Negative 20x minus 20x is negative 40x, and then plus 25. This is still the curve y is in that format. So we're just trying to expand the function of the curve. Now we need to now find the gradient function. That means we need to find dy dx. So dy dx, that is, we are differentiating the function, equals to, what do we get when we differentiate 16x squared? We simply get 32x minus 40 plus 0. So this is the gradient function of the curve, and this is the function that will give us the gradient of the curve at any point on the curve. But now we have a point on the curve. The same point, I have a 9. So we are now going to find dy dx, which is the gradient of the curve at a point I have and 9, equals to, the first one is always x, this is y. So we substitute for x in this function. Substitute for x here. That means we shall have 32, x is a half, minus 40. This equals to, when you press the calculator, 32 times half is 16. 16 minus 40, that is negative 20 something. 32 times a half, 16 minus 40, negative 24. Negative 24. So this is now the gradient of this curve at the point half a 9. Therefore, gradient of the curve is negative 24. So that is how we find the gradient of the curve at a given point. This is the solution to example 2.